Hello friends, welcome to my channel, a channel for learning simple coding. If you find this video to be helpful, please like, share and subscribe my channel. In this video number 43, we are going to learn the use of smart pointer box. How we can use box in Rust programming language and what is the benefit of this that we are going to understand in this video. So first question is dynamic memory allocation. You know that when we allocate a memory on compile time, that is we called compile time memory allocation, or we called static memory allocation, because on compilation time compiler know how much of memory we have to initialize for a particular variable. Like I declare let a equal to 10, that means it know that I32 means 4 byte of memory is going to be stored for a particular variable. But if on compile time compiler doesn't know how much memory is required, or it is not possible to provide a memory in a stack, then we use a mechanism to allocate memory at runtime. Means when your program is executing, during that time we need to allocate a memory on a particular variable. So that concept is called dynamic memory allocation. So this concept we implement in Rust programming language by using smart pointer like box. So in this video we are going to understand how you provide this dynamic memory to a particular variable or a list or some other concept we are going to understand here with the help of box. So let us start. Here I already have this project class 41 to all. I have already explained that later videos I will make in same project. For that I have a module folder. In my previous video I have also explained how to create module in Rust. So one more module I am creating here, and I say smart pointer and I say box.rs. Remember that this box I want to use. For that I create a function use box, simple function, and in this function remember that because it is under a module, so we should declare it pub, means public function should be there. Now here in this function I define the use of box. Suppose I create a variable, I say num equal to 10, and I execute this program like this. It's a very simple. I say num equal to, and you can pass num here also, no problem. So this program is ready, and I just import this here. I declare this here because I want to use this program that is called sp box that I want to import. Remember that I want to add into the module file, that I have this module file, and this module file I want to use in my main file. That's why I'm declaring this as a module or library and declaring it a public. Then in main directory we have a lib.rs, and here we have already declared that this directory is a module. Remember that. Now in main this is not available, so in place of this I have to use sp box. Remember that. And with the help of this xp box I use this function. So I say sp box and the function name is use of box. Remember that. This we want to use. Now if I call this, you will see that it's a simple one, nothing special in it. It say num equal to 10. But the thing to be understand here, the concept that you have to understand here is that when I declare a variable like this, it takes space in a stack because it's a under a function and it's a simple variable. You can say that single data type is not a complex one, skeleton data type. So here it takes space in stack because it's an integer type, float type, long type, all these types of variable. In Rust we have i8, i16, i32, i64, i128. That means all these types of variables take space in stack. Remember that. But the problem is here that if I want to give the space of this particular variable in heap, how can I do that? For that what I have to do, I say here box new. So like that I have to declare this. It's a very simple one. Just inside this box, with the help of new function, we just define this value, and now this value is, you see, take space at runtime, means it's a dynamic memory allocation because box is a smart pointer and it will allocate memory at runtime, and this variable num this time will take memory in heap. So if I try this once again, I run it, no problem in execution, but now this num variable is taking space in heap. Remember that with the help of this box. Now one more example we have of this, if you want to understand that, if we have a enum of list type, and here I say cons list I want to declare, and here I say list I want to store here, then I say nil. Remember that this type of list if I want, then I need to use it, so I say use list, and here I want to use cons and nil like that. And if this list I declare here, now I make it comment, no need of this, I try to make concentration on this list. Now I use this, so I get list equal to, I say cons, here I pass 1, then again under this I need cons, then I pass second, and I say nil. Remember that. So this is the cons list. Cons list means recursive list. Remember that, recursive list, because we have this variable here enum type and we are passing inside this list, so it is the recursive type of list under the enum. So if we declare like this in Rust, then you see that what the error we have. Execute it and you see that it's saying that you should declare this under box RC or reference you have to pass. So we have to declare it like this because it's a use of this. If you are using recursive call, then it must to use box because you need to initialize it in a heap as a dynamic memory allocation. If you do this, then you have to use this also because you are initializing it with the help of new like that. This nil also box new like that we have to initialize this. Remember that like this we have to use it. If I compile it now, you will see that it is working fine without any problem, but no output we have because we are not using this. For using this list, I say match list, then under this I say we have a first pattern, that is list cons, and under this we have a variable a and b. Remember that I need to display this, so I say print, and I can take this under this because I have to print multiple lines, so I say println, and here I say the value of a equal to, and this value I want to print here, remember this one, and this b if I want to read, then again I have to need one more match star b because it's also list. Then I have to check once again, I say list cons, and here I say c, and I don't want to go inside because nothing is there now, and here also I say println, and this time I print the value of c equal to, and here I pass c. Remember that. So this value I want to initialize, and after this here also I say list nil because this we have to also provide like this, and I say print ln, and I say nil list like this we have to use, you see. And this one is because it's a list, so here also I have to use this one, and one more I have to use one time, I have to use nil here, and I say println, and here I again display nil list like this. So you see we are using this list here with the help of match, and if I try to execute it once again, you see it will give 1 and 2 as a value. You see 1, a equal to 1, b equal to 2, c equal to 2, because this value is a, this value is c, and this value is b. So b is again a list, so again we are matching it and we are checking the value and we are retrieving a c, c is 2, and this third one is null. So if you are passing a some cons list, so you can read the value of this, Remember that? Answer is 1 and 2. So with the help of box, we are able to initialize this recursive list inside a heap. Remember that. Otherwise, you cannot execute such kind of code in Rust. If you want to make a linked list, the linked list also uses structures, and structures means self-referencing structure we have to use. And on that situation, to create a linked list, we need to declare that in heap. And to declare those values in heap, we require boxes in Rust. Remember that. It's not so simple, it's not so complicated also, but it's the most useful concept if you want to work on blockchain or linked list concept in Rust programming language. So this much is available in this video. So I have explained you dynamic memory allocation, boxes, and use of box new. If you like it, please do subscribe. Thank you for watching this video.